Hi, scholars. Good afternoon. We are at Unit 2, Lesson 3, Lesson 2.3, Partition Segments in the Plane. And the objective for this lesson is for you to be able to partition a segment in the coordinate plane. What does it mean to partition something? To break it into parts. But specifically to partition a segment, it's really important that you have a starting point, a direction, and a ratio, which is called a partition ratio. Segments with a starting point are called directed segments, meaning we would call segment AB, right? Its starting point A because that's the first letter mentioned, and its end point B. So it's going in a certain direction. Or you can call it a directed line segment, but you'll see this word directed in front of segment, and you'll know that it has a specific and distinct starting point and ending point, okay? Now a partition ratio compares the lengths of the two segments on either side of the partition point. What does that mean? Well, here we're looking at this segment, and we're told that the length of AP is equal to the length of PM, which is equal to the length of MQ and equal to the length of QB. So all of these lengths are equal. Therefore, they're all, of course, the segments are congruent. All of the segments are of equal length, which means they're all congruent. A midpoint partitions a segment into two congruent parts. And in this case, we see the midpoint here being M. Therefore, the length of AM to the length of MB is a 1-to-1 ratio, meaning there is an equal number of units to the left of M as there are to the right of M, okay? So that's what the 1-to-1 ratio comes from. Now, if you think of it as there are 2 units to the left of M and 2 units to the right, a 2-to-2 ratio is the same as a 1-to-1 because if you think of a ratio as a fraction, if you take 2 divided by 2 and you simplify it, you're going to get 1 over 1, which is the same as a 1-to-1 ratio. So even if this has 2 units to the left and this has 2 units to the right, it's still a 1-to-1 ratio. So 1-to-1 ratio just means that you have an equal number of units to the right as to the left. Okay? Regardless of whether we look at directed segment AB or segment BA. What do they mean by that? So whether you look at it where A is your starting point or B is your starting point, there's an equal number of units away from the M, if we use A as a starting point, as there is from B, if we use that as our starting point. That's what this sentence means. Point M lies half of the length along segment AB. So it's halfway along the length from point A, or half of the length along segment BA from point B. Again, so the midpoint is halfway along this segment, whether you're starting from A or B. Point P partitions directed segment AB into a ratio so that A to P and P to B is 1-to-3. What does that mean? So directed segment with A being your starting point, the ratio from A to P, from AP, to PB is thus. AP is 1 unit, but from P to B is 1, 2, 3 units. So P being the partition point, from AP, that's 1 unit. From PB, 1, 2, 3 units. That's why there's a 1-to-3 ratio. But that's if A is our starting point. What about the segment BA if we start from here? So from P to B, it's 1, 2, 3 to 1, okay? So 3 units to 1 if we look at it backwards as in B, segment BA starting with this point. All right, point P lies 1/4 of the length along segment AB from point A. So point P lies 1/4, 1 out of 4. 1, 2, 3, 4. Okay? Sorry, I got to scroll down a little bit. I was reading that part without you guys being able to see it. So this is the last bullet point, and you're just going to write 1/4 here. All right? Let's look at the actual partitioning of a segment. And so here, it says, given directed segment AB, determine the coordinates of point P that would partition the segment into the indicated ratio. So if we're given this directed segment AB, it means that A is always going to be our starting point in this case, because we start with this as the first letter. All right, so directed means that there's a distinct starting point, and in this case, it's A. So if we count the number of units from A to B, 1, 2, 3, 4, 5, 6, 7, 8. There are 8 units from A to B, okay? So this first ratio is 1 to 1. Well, what does that mean? I said earlier that anytime you have a 1-to-1 ratio, it means that there are an equal number of units to the left as there are to the right. So if I have 8 units total, that means that I should count off 1, 2, 3, 4, put my partition point here, and then another 1, 2, 3, 4. So I have 4 units on one side, 4 units on the other. We started with A, and our partition point in this case, P, is going to be 1, 1. Okay. Now what about 1 to 3? So we want a 1 to 3 ratio. We want to break this 8-unit segment in a partition ratio of 1 to 3. Well, how would I do that when I have 8 units? Well, let's think about it. If I take that ratio and turn it into a fraction, right? 1 over 3, and I consider that I have 8 pieces in total. How can I account for those 8 pieces when I have this fraction? Well, what I'm going to do is I am going to find the equivalent fraction that would account for exactly 8 units. This one accounts for 4. That means if we look at it as we're going to have 1 to the left and 3 to the right, that's only 4 pieces. Right? So we also had to do the same thing here. We had to increase this 1 to 1 by multiplying the top by 4, multiply the bottom by 4, and we have 4 over 4, or a 4 to 4 ratio, which is the same as a 1 to 1. So I'm going to do the same here. I'm going to start off by multiplying by 2. And that's going to give me 2 over 6, or a 2 to 6 ratio. Will that cover all 8 units? It will, right? 2 plus 6 is 8. So I'm going to count off 2, 1, 2, put my partition point here, and then count off 6 to the right. 1, 2, 3, 4, 5, 6. And that leaves my partition point. The point that splits it up from 2 to 6 is right here, and that point is -1, -1. All right, let's try it with 3 to 1. Same concept here, right? So it's 3 to 1. Doesn't make that big of a difference, because if you looked at the last one we had, it was a 1 to 3. So all we have to do now is turn it around a bit, okay? So I have a 3 to 1 ratio, and I need to make it so that my ratio, when I add up the number of units that it covers, oh, excuse me, that's going to be 6 over 2, or 6 to 2. If I add up 6 plus 2, it's going to give me 8, which means that I'm doing it correctly. All right, so we're going to count off 6 from letter A. 1, 2, 3, 4, 5, 6, and our partition point goes here, and then count off 2, 1, 2 to the right, 6 to the left, 2 to the right, and our partition point is here, and that is 3. Our coordinates are 3, 3. Alrighty, so what if we try this one? So this one is 3 to 5. You're going to do the last one yourself, but we'll do 3 to 5 together. So we have a 3 to 5 ratio, and that covers all 8 units. If I look at it, there's 3 to the left, 5 to the right, I'm good. That's going to cover all 8. This whole segment is made up of 8 units, and I have 8 units here. 3 to the left, 5 to the right. So all I have to do, and I'm going to actually start doing the unit count down here so we can actually see it. So I don't have to change anything. I don't have to increase the fraction or the ratio in order to make it account for 8 pieces or 8 units. I can leave this the same. I just need to count off 1, 2, 3, put down my partition point, and then 1, 2, 3, 4, 5. Okay? And so my partition point is at 0, 0. It's right at the origin. Okay? It's right at the origin. Right? 0, 0. Okay. So what you are going to do, I just have to find the correct sheet. What you're going to do is you're going to try partitioning it yourself at a ratio of 1 to 3. We're actually going to do this together. All right, so this is not a try it out. So we'll do this together, okay? It says determine the point, but what you should have done by yourself was 7 to 1. Okay, you should have done 7 to 1 yourself, figuring out where its partition point would be. Okay, so do that yourself. Okay. All right, determine the point P that partitions the directed line segment AB into a ratio of 1 to 3, where A is -2, 5, and B is 6, -7. So we're going to plot -2, 5, 1, 2, 1, 2, 3, 4, 5. That's A, B, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7. Okay. And that's B. Then you're going to connect them up. Okay. Now, the thing about this is that it's hard to figure out. It's not like the last one where it was super duper easy to figure out exactly how many units to count this way. So you're just going to make this into a right triangle. And what I mean by that is you are just going to, because you do want to get a nice flat line, and that will help you to figure out how many. Okay, now keep in mind here, that's our A, that's our B. Okay, so here we've made this a nice flat line, and I want you to go ahead and use this as your unit count and do it just like we did in the last example where you're counting at a ratio of 1 to 3. If we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 in total, how can we get this ratio to account for 12 units? Try this yourself, bring it in tomorrow, also do the try it out down here. Okay, and we'll look at it tomorrow. Try it, try the best you can. Don't leave it blank.